In this video, we're going to take a look at max sum with no adjacent values. So the interviewer asks us to create a function that accepts an argument array. So this guy here. And what we need to do is return a maximum sum with no adjacent values. This means that in these examples, maximum sum would be 1 plus 3 plus 5, which means that we return 9, right? If we would, let's say, change this array to have 5, 2 minus 3, and 5, our result would actually become, you guessed it, 10, right? Because we add 5 and 5 in this example. So how would we solve this? One way of solving this would be to use dynamic programming. What we will do is we would create DP array, which can be pre-populated with 0 values, right? Of course, we start at index 0. And what we can do with dynamic programming is just on each stage for each index, right? We can calculate the best or the maximum sum, right? So for index 0, the max sum is this guy here. So we just change 0 to 5 and move our pointer forward. Then on the next stage, index 1, we calculate the best sum between 2 and 5, which is 5, right? We update our dynamic programming. So at this point, we have maximum sums for 0 and for 1. But in order to complete this task, we need to calculate the best sum till the last index, right? Cool. So let's do that. We're at index 2 now. And then at this point, we can update this current index with either previous, which is this value, previous, which is 5, or minus 3 plus this guy here, right? So this is 2. Which one is bigger, 2 or 5? Of course, it's 5. So we can update the 0 to a 5. Move on. At index 3, we can either take 5 or 4 plus 5, which is 9. We can update it to 9, right? It's the biggest sum. And the last index, it's either 9 or 5 plus 5 is 10. And we have our results, right? We just return the last index value from the DP array, right? Okay, so what's time space complexity for this one? So for time, it's O of n. N is the number of elements inside an array. And for space, this solution uses O of n, so linear term, but we can improve the space complexity to use only O of 1. Not use an array, but to use only 2 values, right? We will see this in code. Cool. So let's have an array with 1, 2, 3, 4, 5 values. And if we print max sum, we should get value 9 from this example. So let's do this. Right. So let's create DP array with pre-populated values. So we need to length a. So we get only zeros here. We need to update 0 value, which is a of 0, and DP1 is max between a of 0 and a of 1, like this, right? We can ask our interviewer if we expect to have values that are, so array has at least 2 elements. If not, we need to handle this right here, right? But let's say that the interviewer says that we have an array that has at least two values, which is fine for us. For in range, we start with index 2 and proceed until the last index, which is this guy here, and then inside the for loop we need to update our I value, right? So let's just, for demonstrating purposes, let's do this. So let's populate the array with zeros. We have already pre-populated this guy, and let's change this to 5, right? So when we're at this point, we modify the DP array with 5. The next stage, we do the maximum values between so 2 and 5, which is 5. Like this, cool. And now we're inside the for loop, and we'll be updating this until the end of the array. So this stage we need to populate either with previous values or arrays index value and I minus 2, right? So it's max between dp I minus 1, which is this guy here, or ai plus dp I minus 2, which is basically 3 plus 5, which is 8 in this example, right? Cool. So once we're done, we can just return dp minus 1, which should give us 13, right? So 5 plus 3 is 8, plus 5 is 13. And if we change 3 to minus 3, we should get back 10, which we do. So our first example has an O of n time and of n space, but we can do better, right? So let's try to do it without creating an additional array that we did in this example. So let's do this. Def max sum a. And what we'll have is two variables that will point just to an index or a value, right? So previous is a of 0 and current is a of 1, like this. And then we need to have for loop, which is the same as in the previous example. So we start index 2 till the end of the array, like this. Let's save the current value inside temporary variable, because we'll be all writing this right now. So its maximum, it's between current and a of I plus previous, right? And now we can update our previous value with a temporary value, like this. And after we're done with looping until the end of the array, we can just return the current values, right? And if we change this, we should still get number 10, right? Like this. Oh, it's 7. Okay. Oh, of course. Let's go with it, because this guy has to be maximum value between a of 0 of a of 1. And we get 10. Okay, so that's it for this one. Hope you had a blast, and see you guys next time. Bye.